Hello everyone, my name is Sarabjit Singh and welcome back to my channel. So today I'm going to discuss about Docker, that is a tool, or you can say it is a engine that is used in DevOps model. So basically it is a tool that is used in DevOps model. So what does it mean, how it works? So we are going to discuss basic about the Docker. So I am going to give you a overview how it is, how it works, what are the components, architectures and all. So basically Docker is a containerized applications. We can run containerized application on Docker. Okay, so it means you can build, ship and run any app anywhere. Means it doesn't depend upon any hardware or operating system. It might be anything. Okay, so let's start with its history. So Docker was initially released in March 2013 and it was started as a internal project within Dot Cloud by Solomon Hicks. So basically the original author or the main author of the Docker is Solomon Hicks, and it is platform independent. It means you can run Docker on any platform. It might be on Mac, on Windows, on Linux, any platform, on cloud as well. Okay, and it has a repository that is hub.docker.com. So this is a repository means we have images, many official images that is put over on hub.docker.com. So whenever you are running any container, if it is the image that is going to use by the container, it is not there, then it is going to go search for hub.docker.com and it will search the online repository. If it is there, it is going to download from the repository and it is stored on locally, and then it will start the container. Okay, so we will discuss in the coming slides. So on the next, it is open source main thing, and it is licensed under Apache license 2.0. So it means you can take the code of Docker and you can modify it. You can make the changes in the Docker code and you can make your own variant of Docker, and it can be integrated with various infrastructure tools like AWS, Azure, Ansible, Jenkins, Kubernetes. So basically Ansible and Jenkins, Kubernetes, these are the DevOps tools as well. So the means to get the deployment model correct, means full deployment model, the Docker is one of them. Okay, so using these Ansible, Jenkins, Kubernetes and Docker and other tools also, GitHub. So these tools make a DevOps model, full DevOps model. Okay, and then we can the main thing is like question is, can we run the legacy that is that is run on the operating system? Can we run that application on Docker? Then yes, we can convert that legacy application into a container and then we can run it. Okay, if you can these application can you find on hub.docker.com, that is officially released, means the image is released by official sites. Like if you want to run MongoDB instance, then you can just there is a official image, you can just download it, or you can just run the command, it will automatically going to download locally. Okay, and then the main thing why we need to use Docker. So actually it is going to reduce capex as well as opex cost. So capex means the front end cost, means what to buy the physical servers and the mm, RAM or all the things that is used in IT, and the opex, that is the operational cost to manage those virtual machines and the operating system. For those we need some guy who can handle that, means system administrator, right? We can reduce those costs using Docker. So we will learn how we can reduce the, okay, in coming slides. So go to the next slide and let's start. So virtual machines versus container, okay, what is the difference or why we need it? So first we start from the scratch, means in earlier days we have a physical machine, okay, for each application we need a separate physical machines, okay. Then virtualization come into the picture, and then what happened, we can run multiple application on the same physical hardware, but again we need a separate operating system, or we can say virtual machines, okay, guest machines. So to run any application, we need an operating system at least. We don't need physical machines, different physical machines, but we need a operating system, correct? And then when we create any application for any application, we need some libraries and the supporting some supporting libraries, drivers, or you can say .NET framework if it is on developed on .NET framework. So we have some dependency, right? So we can remove those dependency on in the container application, okay. So how we can do, like first thing, in containerized application we have one physical machine, and then we have host operating system on the physical machine, right? But if you can see virtual machine, we have a physical means infrastructure, and upon physical machines we have a hypervisor that is going to virtualize the hardware, and then we need to install multiple virtual machines on it, okay. On every virtual machine there should be one operating system that is installed, and then we can run the virtual any application on that, okay. So but in containerized application you need only one operating system, okay. So here we are saving our cost on terms of operating system license, because we need only one operating system per physical machine, right? But here you can see we have a hypervisor, but still we need three multiple operating system for three applications, correct? But over here we need only one operating system. On that we have Docker engine installed, and we can run multiple applications on it, okay. So here we are reducing our cost in terms of operating system licensing. And other thing, like in this model, virtual machines virtualization model, you can see we need operating system for every applications, correct? So every operating system gonna consume some memory, some CPU utilization, correct? But here the only one operating system is there. So in terms of resource utilization, we are utilizing the resources much better way in containerized application. Okay, so I hope you have understood the concept of virtual machines versus container applications, correct? Okay, so let's go to the next slide. So this is the Docker engine. When we install Docker on our machine, so we have three things. So first is Docker daemon, and then Docker CLI, and there between REST API that is going to work between Docker CLI and Docker daemon to exchange the data. Correct. So when we install Docker engine, we have Docker daemon that works as a server, and Docker CLI that is work as a client, means you will get a prompt like in command prompt or in our bash shell. We're gonna provide it with a console where we can input our commands to talk with the Docker daemon, okay. So we using Docker CLI we can manage images that is going to use in to run the container, And then the networking part means if there is multiple application, how they're gonna connect with each other. And data volumes, where we can store our data, our application data. So for those we need Docker CLI, and Docker daemon is a main component that is going to talk with the with our hardware, or we can say the operating system kernel. Okay, so this is the Docker engine. Let's go to the next slide and learn about the architecture. Means whenever we are going to initialize any container, what's going to happen in the background. So first of all, when we run this command docker run hello world, so when we run this command on CLI, docker CLI, that is client, it is going to make a API call to the daemon. Okay, so when it when it makes a API call to daemon, it is going to search our local directory first. Is there hello world image is present? So when it gets no, there is no hello world image. So what it is going to do, it is going to connect with that hub.docker.com, that is online repository. Okay, so when it's connect to that hub.docker.com, it is search over there. When if it is there, then it is going to pull that hello world image to the local system, and it is going to store on the local host. Okay, so this is called pull method. Okay, so when it's stored locally, then it is going to run our hello world containerized application. Okay, so they actually in hello world containerized application, there is nothing, just a echo command with some echo some data that is going to populate on our screen. Okay, so whenever any containerized application done with its the whatever what is going to do in the image, it stops. Okay, when it's completely uh, run that image, or you can say that container, whatever written in the container, if it is runs, then it is going to in a stop state. So you will understand these things in coming slide, because it's little bit confusing. So actually I'm going to give you some demo in some other videos. So don't worry if you don't understand. Just remember like how it's work. Okay. So let's go to the next slide and learn about the container. What is container, right? So container is just a unit of a software. Okay. So when if we want to run a application, that is a MySQL application. For example, we want to run a MySQL application. So what we need? We need a virtual machine, correct? And then we have to install the MySQL on it. Okay, but over here we don't need a operating system. If the Docker is already installed, you can just run that MySQL as a container. Means you have to just download the image, and the image is very less in terms of the space or size. Okay, when we talk about the ISO of Ubuntu, we need 2 GB. It's a 2 GB in size, correct? But when we want to initialize an operating system as a container in on the Docker system, it is only 64 MB. So you can just imagine how much difference. This is a 2 GB ISO image, but as a container it is only 64 GB. So in container, what's going to do? It's written on the, so every container is going to work something different. Okay, so it is a standardized unit of a software. Okay, and then lightweight and secure. How it is lightweight means if we want to run a MySQL, so when we initialize a container, it is going to only process that .exe, or if it is a window, it is going to run that process only, MySQL.exe on that container. Okay, so it's a lightweight, it's not going to consume much memory as well as CPU. So, and then secure. Secure means every container has isolated, means it is not going to conflict with each other. So it is isolated, and we have to make a network among these containers so it can communicate to each other and it can store the data as well. So to define a container, we need a Docker file. Okay, this is a snap of a Docker file, how it looks. So if we talk about this snap, so you can see it's written from Python 2.7-slim. So what is going to do? It is going to first download an image from the hub.docker.com of Python 2.7. Okay, this is a parent image, and then it is going to go to this /app directory, and then under app directory, whatever in /app directory, it is going to build a image from there. Okay, and then it is going to run this command that is going to open this requirement.txt, that should be also under the /app. So it is going to check like what are the requirements of the container to initialize. So whatever written in requirements.txt, it is going to again download that libraries, and then you can see if it is a web application, it is going to expose 80 to the outside world, so they can connect with this port 80 from the outside HTTP. Okay, and then environment name is world. Okay, so this is the environment variable, and then it is going to run the main application, that is app.py. So the main application is app.py, that is written by some developer. Okay, and now you can see developer don't have to worry about the requirement dependency, nothing. The require whatever the requirement that is already written in the container file. So that is a container file actually. This is a Docker file that is used in to build a container. Okay, so when we run this command, sorry, so when we going to run this command docker build -t and then the image name, so when we run this command, it is going to create a image locally. So you can put this image anywhere, so it's a run anywhere. Okay, just requirement is the Docker engine, it should be installed on the operating system, correct? So if the Docker engine is there, you can just simply run the application. You don't have to worry about the libraries, nothing. Okay, you can just simply run, it will confirm, it will run, it is going to run, and it is going to work as expected. So that is the main you can say quality of the Docker, means main characteristics. It can run anywhere, any application, anywhere. The developer don't have to worry about like the what is the requirements, and then operation guys can saying that no, it's not working. It's not like that. It is going to work definitely. Okay, so let's go to the next slide, that is about swarm mode technology. Okay, so swarm mode theory. What is swarm mode? In container image, we are going to just create one image, but in production we need multiple images to serve better, correct? So what we are going to do, we are going to use the same image with a multiple container. Okay, so it is basically for high availability. Some more things need to be noted over here. So it requires Docker 1.12 or later, and it is a true native clustering. True native clustering means we have these different engines and then we need to install Swarm. No, when we create a Swarm, when we initialize the Swarm on any node or any engine, so the group of that engine becomes Swarm mode automatically. So we don't need any Swarm from on top of that. Okay, like a hypervisor on the bare metal, correct? I hope you understood. So in coming slide, you are going to again going to little bit confused, but try to differentiate between these terms, right? Okay, so Yeah, the third thing is swarm mode must be enabled. So when once we initialize the swarm mode in the any engine, it already becomes as a group of like if we initialize on these 8 engines, then it is going to automatically create one mode, swarm mode. That's called swarm mode. Okay, so it's a true native clustering. You don't need other to like make a group. Okay, we don't need any other software to make a group of that engines. So to initialize any engine to swarm mode, we need to run this command docker swarm init. Okay, and the port is 2377. It should be open for outside the world because 2377 is recommended. Otherwise, some application going to throw some error. So it should be noted. Okay, so this is the swarm mode, and let's let's go to the some terminology about the swarm mode. So a cluster is just a swarm. Means when we initialize a swarm mode on any engine, it becomes a cluster. If we are going to initialize swarm mode in two engines, it is going to make a cluster automatically. Okay, so swarm mode, that's I have already discuss. Then the manager nodes. So when we initialize that swarm mode on the first engine, that becomes the manager node. Okay, it is going to manage others. So then we have some worker nodes that is going to join the manager nodes. Okay, for high availability there should be more than one manager nodes. Okay, but among those manager nodes, one should be leader that is going to lead. Okay, so if one leader is not working as expected, then it's the task is or the role is assigned to another manager node. Okay, so worker node is like it works as a supporting to the manager. Means manager node is working going to do the same thing as a worker, but it has a extra role, just extra responsibility to handle the other worker nodes. Okay, so on each worker nodes there should be a task that is assigned by the manager nodes, and then it is going to run. So task is just simple a container, or you can say an application. Okay, and for the services that we are going to discuss in the next slide, here it is. Services container in production. Container in production means when we are going to run containers in a production, we need some scalability. Okay, and some conditions like if something happens, what should be the next mode, or what should be the next step. So these steps is going to handle by the manager nodes, right? So what is the desired state and what is the running state? So let's see. The desired state is we need this service as a 5 replica. Okay, and we have 5 nodes. So how you gonna it gonna run one replica, one service on one node per node. Okay, so let's assume like one worker node is down. Now we have 4 machines. Okay, so let's understand the scenario over here. So let's assume we have 5 services running on each server 1 1. Okay, so we have one service over here, one service over here, one service over here, one service over here, one service over here. So we need 5 services, means 5 replicas running on 5 different machines. Means we have 2 manager nodes and then 3 worker nodes, and between manager nodes we have one leader. So there is one mistake once again. So we have 2 manager node and 3 worker nodes. So we want 5 replica of a service. So manager node has distributed one application on each machine. Now what's happened? Let's assume once machine goes down. So let's assume this machine is now, it is not working now. So we need 5 services. What here we have only 4 services running. So it will check what is the desired state. The desired state says 5 services needs to be running, but now it's only 4. So manager node, what it will do, it will start a new service on any of one machine. Let's assume it started over here. So now we have 2 services running on this worker node and other have these 3. Okay, so total now 5 services. Again we have desired state equal to running state. So I hope you have understood the concept. Okay, let's go to the slide once again. So we have this YAML file that is very human readable file. You can easily run. So version is a 3, services and web, which services, images, which image you have to put over here. We need 5 replicas, how many CPUs, memory, or restart policy. Once if one is failure, then we can restart another one. Okay, and this is the port configuration, network. Okay, so these are the configuration in YAML file. Okay, let's go to the next, that is stack. So what is stack? Again same thing, we need 1.12 experimental build or later to create a stack. So a stack is a fully production based application. Okay, so we can run different application with multiple services. Okay, so let's assume we need one voting app, that is Python app, and we need one Redis application, we need a .NET application, and we have one DB and then a result application that is written in node.js. So these 5 different services running on one stack, that is called stack. Okay, so there should be more than one Python application, more than one Redis, more than one worker, and all of these 5 components have multiple instances, or we can say services. So the group of these services called as a stack. Okay, to make a stack we need to run this command, docker stack deploy, and it has a file .dab that is going to use as a to start a stack. Okay, so the file contains like how many services of Python we need, how many Node.js we need, or what are the different application we need first of all. Okay, and then how many of that, like Python, how many Python services we need to run. Okay, so I hope the concept is clear. Let's go to the next slide, that is facts about the Docker. So it is 300% time, means the organization who has adopted this Docker tool, it can triple the time of the delivery time. Okay, so it can market triple time faster. Okay, and then 13 times more developer productivity. So it can uh, increase the developer productivity by 13%. Okay, it is going to remove the dependency that is used by the application. Okay, so before they have to worry about the dependency, like the application the developer is going to develop, it is going to work over there or not, what are the dependencies that needed, Okay, now developer can create an application or develop a application that can surely run on any platform. Okay, so that is it remove that dependency layer. By removing that dependency, it increases the productivity of developer by 13%, 13 times, not the percent. Deployment velocity. So deployment velocity we can increase by 60%. We can deploy the application fast because we don't have to wait for the VM to be created. We can just run the application in a single, just we have to fire one command, just that's it. And then we can reduce the IT infrastructure cost that we have already discussed. And then operational efficiency means it automatically reduce the errors that comes in our production. Okay, so it is going to automatically increase the efficiency of our operations, IT operations. And then 72% issue resolution, so it is going to increase the MTTR by 72%. Okay, so the reference I have taken from the docker.com, and then I have watched some videos on Pluralsight and uses the Google image. So you can also go to the Pluralsight if you want to know about the subscription of Pluralsight. I can give you, or I can let you know how to get the 3 month free subscription of Pluralsight. Okay, thank you. And for question and answer, you can comment on in the comment box for your queries and questions. Okay, bye bye, thanks for watching.